So we have to do the second question onwards, find the maximum minimum values. Um, this is the one we are doing, second question. So f of x equal to mod x plus 2 minus 1. How are you now? Are you feeling okay? Good. So let's consider this as y, f of x is y, mod x plus 2 minus 1. Then y plus 1, wherever mod is there, you have to do this, the squaring stuff. Okay. So that's a mod x plus 2. So square both sides. When you square, you have y plus 1 whole square equals to x plus 2 whole square. The mod is gone basically. Now differentiate both sides with respect to x. So left side 2 into y plus 1 into dy by dx equals right side 2x plus 2 into 1. Change it. So the 2 gets cancelled. So you'll have dy by dx equal to x plus 2 divided by y plus 1. Now we have to talk about what is the maximum or minimum values for this. So dy by dx can be 0, if x plus 2 is 0. That means at x equal to minus 2. So let's suppose we substitute x equal to minus 2 in the y. So y was mod x plus 2 minus 1. So when I substitute y value, maximum value or y at x equal to minus 2 equal to, this is 0 and minus 1. So y is equal to minus 1 is what we have. We need to see on both sides as we do that, right? So let's say we have minus 2 and you have another value minus 3 and you can have minus 1 or 0. So let's check at 0 and minus 3 what is the value. So y at x equal to minus 3 equal to minus 3 plus 2 minus 1. That becomes 1 minus 1, this is 0. So the next value is y is equal to 0, y at x equal to 0. That's equal to 0 plus 1 minus 1. That's 1 minus 1 is again 0. So you have three values, 0 and that is x equal to minus 3. This is the y value at x equal to minus 3. And at x equal to minus 2, that's minus 1. And x equal to 0, y equal to 0. So this minus 1 is the minimum value. Therefore, at x equal to minus 2, f of x is minimum. And minimum value is minus 1. So that's the answer for the first one. Now we'll go to the second one. This is the second one. So g of x equal to minus x plus 1 mod x plus 1 plus 3. It's almost similar. Only when the mod is there, we have to do accordingly. So g of x is minus mod x plus 1 plus 3, minus mod x plus 1 plus 3. So we'll consider this as a y is equal to mod x plus 1 plus 3. So you got y minus 3 equal to minus mod x plus 1, square it. So you'll have y minus 3 squared equal to x plus 1 squared, minus goes off. So from here, then you differentiate, then you'll have 2 into y minus 3 into dy by dx equal to 2 into x plus 1 into 1. So the 2 gets cancelled. Therefore, dy by dx equal to x plus 1 divided by y minus 3. So as we equate dy by dx to 0, then we have x plus 1 equals 0 and x equals minus 1. So we have to now try three values. X equal to minus 2, minus 1 and 0. So this is our interest. So y value at x equal to minus 2 equal to minus of minus 2 plus 1 plus 3, minus this fellow becomes plus 1, that's why minus 1 plus 3. So you've got 2. So this value is 2. So at x equal to minus 1, we substitute into minus 1, you get a 3. So y at x equal to 1, rather x equal to minus 1, so it's minus 1 plus 1 plus 3, that's equal to 3. So third value at x equal to 0, y is equal to at x equal to 0, so you'll have minus 0 plus 1 plus 3, minus 1 plus 3, which is 2. So you got 2. So this is higher than these two. Therefore, y is maximum, or g of x is maximum at x equal to minus 1. And the maximum value, that means g of minus 1 equal to 3. So that's how we have done these two questions. So the next one is a trigonometric. Sine 2x plus 5. Fourth one is sine 4x plus 3. So these two are the trigonometric questions. So let's try these things in a separate page. H of x equal sine 2x plus 5. So let's say y equal to sine 2x plus 5 dy by dx equal cos 2x multiplied by 2 plus 0. So basically this is 2 cos 2x. So equate dy by dx to 0.
Yes, sir.
So then you have 2 cos 2x equal to 0. This is solving a trigonometric equation. So that implies cos 2x equals 0. So that is 2x equal to either pi by 2 or 3 pi by 2 or 5 pi by 2, like that. So this is 1 pi by 2, 3 pi by 2 or something. So we can say x is equal to pi by 4, 3 pi by 4, 5 pi by 4, and so on. So we need to find out at this value of x, what is the y value. So we will make a table.
Sir.
Yeah, x and y. So when we say pi by 4 is what we are considering, pi by 4 is 45 degrees. So we will consider 30 degrees, which is pi by 6, and pi by 3. This is a 60 degrees, this is 45 degrees, this is 30 degrees. So we will see whether it's a maximum or a minimum at these points. So at pi by 4, we are substituting y at pi by 4 equal to sine 2 into pi by 4 plus 5. So that becomes 1 plus 5, which is 6. So we got 6. Now let's try at pi by 6. So what's the value at pi by 6? So y at pi by 6 equal to sine 2 into pi by 6 plus 5. So this is 2 3s are. So that is sine 60 plus 5. 1.73. This is root 3 by 2. Root 3 by 2. Sine 60 is root 3 by 2 plus 5. That's equal to 5.866. This is 5, this is 0.866. So you got 5.866. And we want to try y value at pi by 3. So that's equal to sine 2 to pi by 3 plus 5. Sine 2 pi by 3 is nothing but sine 120 degrees plus 5. Sine 120 is same as this one. So 0.866 plus 5. So you get 5.866. So since this is greater than these two values, since y of pi by 4 is greater than y of pi by 3, and y is pi by 4 is greater than y of pi by 6, so f of g of x or h of x, this is h of x, I think. So h of x is maximum at x is equal to pi by 4, and that maximum value is 6. So that's how this question is done. The next part is f of x is mod sine 4x plus 3. So everything is inside the mod. F of x equal to mod sine 4x plus 3. I think I wrote correct. And 4x plus 3 mod correct. So we'll go ahead and say y is equal to sine 4x plus 3, and we square it. So we'll say y square equal to sine squared 4x plus 3, then differentiate. So wherever we have mod, we'll have to take the square. This is 2y into dy by dx equal to 2 sine 4x plus 3, and for sine it is cos 4x plus 3, and for 4x plus 3 chain rule is 4 multiplied by 4. So basically you will have these two gets cancelled. So you have dy by dx equal to sine 4x plus 3 cos 4x plus 3 multiplied by 4, that is this 4, divided by y. So this can be written as dy by dx can be written as, we write 2 into this remaining thing will be sine 2 into 4x plus 3, this is sin 2a formula, divided by y. So equate dy by dx to 0. So which means we'll have sine 2 of 4x plus 3 equals 0. So it can be 0 degrees or pi degrees or 2 pi degrees or 3 pi degrees, like that it continue. So assume that we have a 0 degrees. So that means 2 into 4x plus 3 equal to 0 degrees. That means 4x plus 3 equal to 0, x equal to minus 3 by 4. So now we have to try two values, other side of minus 2 by minus 3 by 4, x equal to, say this is minus 3 by 4. So minus 3 by 4, and this side will have minus half.
Okay,
So
sir.
we'll have, yeah, 0 minus half minus 3 by 4, and this minus 1. Let's try these things, what we get. Okay. So because this is in radians, so we have to see, when I put minus 1 for x equal to minus 1, so the mod sine 4x plus 3, in that we have to put minus 1. Then I'll have minus 4 plus 3 mod of sine minus 1. So this is nothing but sine 1, whatever it is, sine 1. Okay. So, and we'll write that as a sine 1. Then for minus 3 by 4, y at x equal to minus 3 by 4. So mod sine 4 into 3 by 4 plus 3. That's equal to sine 6. Then the next value, y at x equal to minus half. That's equal to mod sine minus half. So 4 into, this is minus 3 by 4, right? Oh, this is minus 3 by 4. So this minus 3 by 4, then you'll get 0 basically. This is sine 0, this is 0. So this is 0. So 4 into minus half plus 3. So this will be minus 2 plus 3, and therefore you'll have sine 1. So this sine 1. So definitely sine 1 is greater than 0. So that's what we'll be writing. Sine 1 is greater than 0, which means at x is equal to minus 3 by 4, whatever is the function, that is this sine 4x plus 3, has minimum value. Minimum value. And the value is, the minimum value is 0. That is the center of the table. This is that minimum value. So this is that minimum value. Okay, so that's how we'll be doing this. I think there's one more question in this. H of x is equal to x plus 1, and the x is between minus 1 and 1. That's it. So x plus 1, so we'll do h of x equal to x plus 1, and x belongs to minus 1, 1. I think, right? That's what it is. Minus 1, 1. Correct. Okay. So y is equal to x plus 1. 3, 4, 5. I think this is the fifth question. So then we have to just do dy by dx. That's equal to just 1. So dy by dx value equal to 1. That means it cannot be 0. So no maximum, no minimum. That's the answer for this. All right. So we are going back to the previous page where we got done the questions. So the entire second question is done. Now we have to the third question. The third question just says, find the local, find the local maxima and local minima. If any of the following functions, find also their values, as the case may be. The local meaning wherever you see that particular thing. Okay, that means in one particular place you will have a minimum or maximum. So the first one I'll explain with the graph what they mean by that. Okay, so f of x equal to x square, graph will be like this. This is the f of x is equal to x square. So we know that this is the place where it is minimum. This one is when you take x common, you'll have x to x squared minus 3. Then this x squared minus 3 can also be written as x minus root 3, x plus root 3. So like that. That means at three places it will it will cross the x-axis. But our method is to differentiate and do the things. Okay, that's what basically we don't do the graph. We have to differentiate and then find out local maximum, local minimum. Okay, so we will take this page here and this here. 3 1 f of x equals x squared, and so I'll write as f dash x equal to 2x. So f dash x equate to 0, that means 2x equal to 0, that means x equal to 0. So at x equal to 0, f of x is either maximum or minimum. We need to be trying how do we get this. Okay, so we have a second derivative test. That second derivative test basically means we do one more differentiation. That means try f double dash x. This is called a second derivative test. So f double dash x equal to, that means you are differentiating this 2x, so you will get 2. So what the test says, if f double dash x for that value of whatever we are trying, this x value, right, is greater than 0, then f of x is negative or minimum. Greater than 0 we call it minimum at that point, and therefore we say that f of x is equal to x square has minimum, local minimum, in fact it's a local minimum, at x equal to 0. What is the minimum value? Minimum value is f of 0, that's equal to 0 square, which is 0. So that's what the answer. We said it is a minimum, and the second one is the minimum value is 0 square. So that's how we do the questions. Second one, x cube minus 3x. F of x is x cube minus 3x. You want to ask any question, Sam? Do you have any question?
No, sir, no,
No,
sir.
no, all right. Yeah. Yes. All right. So we will be doing the second derivative test like that one. We will have first derivative and second derivative. The first derivative f dash x equal to 3x squared minus 3. So equate to 0. So we equate to 0. That means 3x square minus 3 equals 0. 3x square equal to 3, x square equal to 1. That implies x equal to plus or minus 1. So we have two values, plus 1, minus 1. So let's see first f dash double dash x. F double dash x, that means I'm differentiating this. I get 6x. I'll have to try now f double dash 1 is how much, and f double dash minus 1 is how much. So f double dash 1, that means in this I'll get 6. F double dash minus 1, I get minus 6. So this is greater than 0, this is less than 0. And therefore, where greater than 0, f of x is minimum. F of x meaning here f of 1 is minimum. Here f of 1 is maximum. So the minimum value will be f of 1. That means f of 1 equal to x cubed minus 3x. Is that the function? X cubed minus 3x. 1 cubed minus 3 into 1. That's equal to minus 2. F of minus 1 is maximum. So f of minus 1 equal to minus 1 whole cube minus 3 into minus 1. So this is 2. So that's minus 2, this is plus 2. So done. So third one, h of x is equal to sin x plus cos x, and you have the interval 0 less than x, that means between 0 and pi by 2, sin x plus cos x. So third one, f of x equal to sin x plus cos x, x is between 0 and pi by 2. So f dash x equal to cos x minus sin x. So we are equating this to 0. Equate f dash x to 0. That means cos x minus sin x equal to 0. So that is cos x equal to sin x, which implies 1 is equal to tan x, or x is equal to tan inverse 1. That is 45 degrees swing. So for other places also it will be 1, because it's a 45 degrees also is 1, and 225 degrees also it's 1, 180 plus 45. But since x is to be belonging to 0 to pi by 2, we consider x equal to 45 degrees only. Now we have to see f double dash x and then substitute this 45 degrees. When you do double dash, that becomes minus sin x minus cos x. That's equal to minus sin x plus cos x. And now I will check f double dash 45 degrees. That's equal to minus sin 45 plus cos 45. Then I get minus 1 by root 2 plus 1 by root 2. That's equal to minus 2 by root 2. That is minus root 2. So f double dash 45 degrees is less than 0. So that implies f of 45 degrees is a maximum. So we need to find the maximum value. So f of 45 degrees is sin 45 plus cos 45. This is 1 by root 2 plus 1 by root 2. That's 2 by root 2. So it's root 2. So root 2 is the maximum value for that.
Yes, sir.
So fourth one, similar. but you have sin x minus cos x, and the interval is also 0 to 2 pi. Okay, so all these questions are just 2 or 3 marks only, not more than that. All this whatever, but highly likely you will get a likely question you may get here. Okay, so I will cut this off, all these three, and put it in the next page. F double dash x equal to cos x minus minus sin x, that's equal to cos x plus sin x. This is f dash x, not f double dash x. So f dash x. So equal to 0. That means cos x plus sin x equal to 0. So sin x equal to minus cos x. So that means tan x equal to minus 1. So tan value is minus 1. That means it must be here or here. The value must be here or here. So we'll just say x is equal to tan inverse of minus 1. So the values that satisfy are 180 minus 45, that's 135, x can be 135, or this is minus 45, that means 360 minus 45, that means 315 degrees, and 45, 360 plus 45 is 405 degrees, etc. So in values of pi, this is pi minus pi by 4. This one is 2 pi minus pi by 4. And this is 2 pi plus pi by 4, if you want to put a pi value. So this is 4 pi minus pi is 3 pi by 4. This is 8 pi minus pi is 7 pi by 4. This is 9 pi by 4. So the two values that can help is both this one and this one. This is beyond 2 pi. So this is invalid. So now we will make a table for these values. Well, we can do second derivative test actually, we don't need a table. So second derivative test. So first derivative is cos x plus sin x. So we are doing the second derivative, f double dash x equal to minus sin x plus cos x. And now we have to try f double dash at 3 pi by 4 is how much? F double dash at 7 pi by 4 is how much? So minus 3 pi by 4, sorry, just 3 pi by 4, that is minus sine 3 pi by 4 plus cos 3 pi by 4. So where is 3 pi by 4? 3 pi by 4 is this, pi minus pi by 4. This is the 3 pi by 4 one. So in this place, sine is in the second quadrant, sine is positive. That's why we have minus 1 by root 2. This is 1 by root 2. But cos is negative. That means you have minus 1 by root 2. So you have minus 2 by root 2. So this minus 2 by root 2 will be minus root 2. So 1 is sufficient actually. We have already done f double dash 3 pi by 4 is already less than 0. That implies f of x is maximum at x is equal to 3 pi by 4. If this is maximum at this place, the other place will be minimum. So that also implies that f double dash 7 pi by 4 will be greater than 0, and f of x, f of 7 pi by 4 is minimum. Basically, this is local minimum, this is local maximum. Why we heard the word local? Because we are restricting that only between the intervals 0 to 2 pi. Because there are other maximum, other minimum also. Now we need to find both these values. F of 3 pi by 4 is cos 3 pi by 4 minus sin 3 pi by 4. Cos 3 pi by 4 is negative minus 1 by root 2, and this one is 1 by root 2. So this is minus 2 by root 2. This is minus root 2. So let's see whether we have done correct only. So f of x is sin x minus cos x, not cos x minus sin x minus cos x. So this is not correct. So sin 3 pi by 4 minus cos 3 pi by 4, that's equal to 1 by root 2 minus minus 1 by root 2, because this is in second quadrant. So you'll have 2 by root 2. So you'll have plus root 2. That's the maximum value. This is the maximum value. So the minimum value will be f of 7 pi by 4. 7 pi by 4. So sine 7 pi by 4 minus cos 7 pi by 4. 7 pi by 4 is here. This is the 7 pi by 4 value. So if it's 8 pi by 4, you'll have 2 pi. So this is the 7 pi by 4. So sine 7 pi by 4 is negative minus 1 by root 2. Cos is positive, that's minus 1 by root 2. So minus 2 by root 2. So minus root 2. So the minimum value is this. This is the minimum. And that's the maximum value. So that part, the trigonometric thing is done. Now the fifth question is cubic equation. X cube minus 6x square plus 9x plus 15. X cube minus 6x square plus 9x plus 15. So this is fifth one. So procedure is exactly same. So we'll take f dash x equal to 3x squared minus 6x plus 9. So equate this to 0. So then you'll have 3x squared minus 6x plus 9 equal to 0. Divide by 3. So you get x squared minus 2x plus 3 equal to 0. Factorize it. You'll have x minus 1, x plus 1, x minus 3 equal to, something is wrong. So this is minus 2x and then plus 3. Did I copy it correct? X cube minus 6x squared plus 9x plus 15. This is 3x squared. Oh, this is 12x. Yeah, there's something wrong. That thing is wrong. So this is 3x squared. This is minus 12x plus 9. So equate to 0. Then we have 3x squared minus 12x plus 3 equals 0. Divide by 3. X squared minus 4x plus 1 equals 0. So these are the roots we need to find now. So minus b, that means 4 plus or minus square root of b square minus 4ac. B square is 16 minus 4 divided by 2. It's equal to 4 plus or minus 16 minus 4 is 12. That means 2 root 3 divided by 2. So we have 2 plus or minus root 3. So these are the two values what we need to be checking. Okay. So So x equal to 2 plus root 3 and x equal to 2 minus root 3. So I have a doubt whether we have done correctly or not. So let's go back and check one more time. So 3x square minus 12x plus 9. So when we divide by 3, so this is, oh, again another mistake. Wow. This is 9. If that's 9 and this is 3, then all this is not correct. Because I was remembering, like, how come we get the so much odd values, so this is not correct. So x squared minus 4x plus 3 equal to 0. Then this is x minus 1 into x minus 3 equal to 0. So x equal to 1 or x equal to 3. So we need to check at these two values. These are the local points. I'll go with f double dash x now. That means I differentiate this fellow, differentiating that fellow. So we'll have 6x minus 12. So I had to substitute f dash of 1 and f double dash of 3. So I need to check, see whether it's greater than 0 or less than 0. F double dash 1 is 6 minus 12. This one is 6 into 3 minus 12. This is 18 minus 12, which is 6. This is minus 6. Since f double dash 1 is less than 0, f of 1 has a maximum value at x equal to 1. F double dash 1 double dash 3 is greater than 0. Therefore, f of 3 is a minimum value. And we need to find both maximum and minimum values. So, f of 1 equal to x cubed minus 6x, right? X cubed minus 6x squared. That means 1 cube minus 6 into x squared plus 9x plus 9 into 1 plus 15, I think. So this is 24, 24 minus 24 plus 25, 25 minus 6, it's 19. F of 1 is 19. So that means this is a maximum value. We need to find f of 3. So f of 3 will be 3 cube minus 6 into 3 squared plus 9 into 3 plus 15. So that's equal to 3 cube is 27 minus 9 6 are 54 plus 9 threes are 27 plus 15. So this 27 gets cancelled. The 27, 27, 54 gets cancelled. So 15. So f of 3 is 15. So since f of 3 is less than f of 1, f of 3 equal to 15 is maximum, is minimum, sorry, is a minimum value. Okay, so
Yes,
we
sir.
have done this also. Next one is x by 2 plus 2 by x. X by 2 plus 2 by x, this one. So we will go for x is greater than 0, g of x. G of x equal to x by 2 plus 2 by x and x greater than 0. So we will do g dash x, that means half. This is minus 2 into minus 2 by x squared. That's equal to 1 by 2 plus 4 by x squared. This is g dash x. G double dash x We can equate to 0, right? We have to equate to 0 first. Equate to 0. Then you have half equal to minus 4 by x square, cross multiplication, x square equal to minus 8. So it is an impossible thing. You can't have x squared to be minus 8. So you will have neither maximum nor minimum. Nor minimum. Okay. So then the next value is g of x is 1 divided by x squared plus 2. 1 divided by x squared plus 2. So g dash x, yeah, okay, minus 2 by x squared plus 2 whole squared into 2x. You can do u by v rule also, you will get this. So g dash x equal to minus 4x divided by x squared plus 2 whole squared. So equate to 0. So once equate to 0, that means x equal to 0. So
Okay, sir.
now we have to do g double dash x. G double dash x is again a big one. So g double dash x u by v rule x square plus 2 to the power of 4, u dash is minus 4 into v is x square plus 2 whole square minus u is minus 4x, v dash should be, v dash is 2 into x square plus 2 into 2 to 2x. So here did we do correct? 2x, everything is correct. So this is what is g dash x. Now we have to try what is the value of g double dash 0. G double dash 0, you substituting 0 into that. So you'll get minus 4, 2 whole squared plus 4 into 2, 4 into 0 into whatever, because it's 0, divided by 2 to the power of 4. So you'll have minus 4 into 2 square divided by 2 to the power of 4. So anyway, this is negative. This is negative. Since it is negative, since g double dash 0 is negative, that means g of 0 is the maximum value.
Okay, sir.
So to find out the maximum value, we have to substitute g of x 1 by x square plus 2, g of 0 equal to 1 by 0 plus 2. That's a half. So half is the maximum value. Okay, done.
Okay,
Then,
sir.
yeah, last question, f of x equal to x into square root of 1 minus x. X into, I'll do next page. X equal to x into square root of 1 minus x. This is the eighth one. So we have to use UV rule in order to get f dash x. So f dash x equal to, this is u and this is entire thing is v. U dash is 1 into v plus uv dash. So u is x, v dash is 1 by 2 root 1 minus x into minus 1. So we have square root of 1 minus x. This becomes minus x by 2 root 1 minus x.
Okay,
So
sir.
we have to first take LCM and get one single fraction. Then have 2 into square root of 1 minus x. This will have 2 into 1 minus x minus x. That's equal to 2 minus 2x minus x. divided by 2 root 1 minus x. So for this to be 0, for f dash x to be 0, that means we have to equate the numerator to 0. That means 2 minus 3x equal to 0. That means x equal to 2 by 3. So we need to check now f double dash 2 by 3. So that means we need to find f double dash x. So f dash x is this square root of 1 minus x divided by that. So first thing is f dash x, the square root of 1 minus x minus divided by 2 root 1 minus x, and this is, I think, x, correct. So f double dash x will be, differentiating this, you will have 1 by 2 root 1 minus x and chain rule minus 1 because minus x is there. Now for this u by v rule, this is v square, that means 4 into 1 minus x, and u dash is 1 into v is 2 root 1 minus x minus uv dash. So u is x, v dash, that means for this 2 to 1 by 2 root 1 minus x into minus x. So we have to simplify entire thing, or without simplifying we can just substitute our value. We have to substitute 2 by 3. 2 by 3 in this, definitely you have to use a calculator. So you get positive or negative, that's always the thing. So we have, this is minus 1 by 2 square root of 1 minus 2 by 3 minus bracket 1 minus 2 by 3, and in this 2 square root of 1 minus 2 by 3 minus, and this minus minus becomes plus, so 2 gets cancelled. So x squared, this is 4 by 9 divided by square root of 1 minus 2 by 3. So we have to look at, this is negative value, this is also negative value. Okay, so we don't need
Yes,
to
sir.
actually calculate, so you'll get a negative value. So then you have to write, since f double dash 2 by 3 is negative, f of 2 by 3 is maximum. So we have to find f of 2 by 3. So we know f of x equal to 1 by x into square root of 1 minus x. So f of 2 by 3 will be 2 by 3 square root of 1 minus 2 by 3. So that will be, oops, don't need settings. Let's go somewhere. Yeah. So this is equal to 2 by 3. This is square root of 1 divided by square root of 3, because like that you'll get. So 2 divided by 3 root 3. This is the maximum value. So with that, that part is done. That exercise part is, I mean, that third question is done. So we have now fourth question to continue. Okay. Any doubts or questions or anything you have? I can start with the fourth question, but we still have time. That's why.
No, sir.
No. Yeah, okay. So let me take the fourth question. Prove the following functions do not have maxima or minima. That's what is the fourth question. Of course, these are the important questions, as I said. So I'll take this fourth one and put it into a separate page and I'll do it. Okay, so all similar actually, very very similar. And so first one is f of x equal to e power x. I draw sometimes graph just to know that how the you get some meaningful thing. Okay, e power x, you give different values. When x equal to 0, that's e power 0, we'll have 1. So e power 1 will be e. So we'll be having some other value, 2.17. E power 2 will be like that. So the function, when you plot it, will be like that. So it is above the x-axis. It is never below the x-axis. Okay. So now let's see what he is trying to say. F dash x, e power x differentiation is e power x only. And now we have to see for what value of x, e power x is 0. That means at any point is it touching this x-axis? No, for no value. That means e power x cannot be equal to 0. Therefore, there is no maximum, no minimum for f of x. So the second question, g of x is log x. So very similar explanation. G dash x equal to 1 by x. So 1 by x cannot be 0, or 1 by x is 0 for x equal to infinity. X equal to infinity doesn't exist. Okay? Therefore, g of x does not have a maximum or minimum. So third one, h of x is x cube plus x square plus x plus 1. H of x equal to x cube plus x square plus x plus 1. So when I differentiate this, h dash x equal to 3x squared plus 2x plus 1. This is 3x squared plus 2x plus 1. So when you actually plot it, then you have to do with the what do we call completing the squares. So you will have 3 bracket x square plus 2 by 3x plus 1. Then you will have 3 x square plus 2 by 3x plus, so half of this 1 by 9 minus 1 by 9 plus 1. So you'll have 3 into x plus 1 by 3 whole square minus 1 by 3 plus 1. So you'll have 3 into x plus 1 by 3 whole square. 1 minus 1 by 3 is plus 2 by 3. So this is h dash x.
Okay, sir.
So if you actually plot this second one, I mean for this also, let me, this is having at minus 1 by 3, it's 2 by 3 value. So the vertex is minus 1 by 3, okay, comma 2 by 3. So this is minus 1 by 3 and the value is 2 by 3. So this will be going like that. What is this? This is h dash x. So it is not cutting the x-axis. Okay.
Sir.
So that is the explanation we have to write. H dash x can not be 0. Therefore, h of x neither has neither maximum nor minimum. Yeah, it is better to draw the graph for this. Okay. In fact, that's the reason they give this question, to do all this completing the squares and all this stuff. Okay. So
Okay, sir.
we are done for the day. So I was asking you, are you all right now? Are you